Everybody. I'm Rakhi. As Jessica told, I'm a grad start tutor at USP, and welcome to Statistical Workshop Part 2. So today we'll be discussing some basic statistical concepts. We'll first of all start with PDF, probability density functions, and after a brief introduction about that, we'll start hypothesis testing, and then we'll discuss some examples. And then there are some basic tests which we do for hypothesis testing, like z-test, t-test. So we'll discuss that. Towards the end, we'll discuss confidence interval, the type of errors we can perform, and at the end, we'll tell you about our academic support center. So let's start with some very basic definitions like discrete and continuous variables. So, what are basic? What is a discrete variable? So, a discrete random variable is anything which can take distinct values or a finite number. So, when I say finite number, I mean it's like 0, 1, 2, 3, 0, 1, 2, 3, 4, or anything like that. So, basically, a variable which we can count. So, some of the examples include number of students present. So, we can count number of students in a class. Or another example could be number of red marbles in a jar. So basically these are things which we can count. So suppose in an experiment, you can count number of heads while flipping 3 coins. You can count students' grade level. So basically it's A plus, B plus, something like that. So all these examples are of discrete variable. Next we have continuous variables. So continuous variables are basically defined as a variable which can take an uncountable set of values. Uncountable set of values as in infinite values. So basically these are the variables which are obtained by measuring. So examples are height of students in a class, weight of students in a class. So when I say infinite values, I mean a height could be 156 centimeter, 156.5 centimeter, 156.56 centimeter. So there is no definite or distinct value. Same goes for weight. So it could be 160 lb, 160.1 lb, 160.12 lb. So it can go on and on. Some other examples include time it takes to get to school or distance traveled between classes. So these are some basic continuous variable examples. Another point to note is continuous variables would take forever to count. So basically, let's take an example of age. We cannot count age. It can be literally anything. It could be just 37 years or 37 years, 9 months, 6 days, 5 hours, 4 seconds. So we can just keep on counting. So again, age is a continuous variable. Number of stars in the space. Again, you cannot count number of stars. You can start by counting 1, 2, 3, 4, but then it will go to infinite. So it is an example of continuous variables. Moving on, after studying discrete variables and continuous variables, we'll discuss something as probability density function. So basically, it tells us the probability that, what is the probability that the random variable x will be between a range of value, like let's say a and b. So basically, probability density function measures the probability that a particular random variable will fall into a particular range. So as it says, it produces the likelihood of values of the continuous random variable. And there are two distinct terms, PDF, that is probability density function, and there is another term, PMF, probability mass function, or CDF, cumulative distribution function. So PDF are basically used for continuous random variables, and PMF or CDF are for discrete random variables. They both calculate the same thing, but one is for continuous random variables and other one is for discrete random variables. So now continuous random, we are discussing probability density functions. So we'll be talking about continuous variables. So as we just studied, continuous random variables can take infinite number of values. So there is no sense calculating the probability for a particular value. Like for a continuous value, it does not make sense to calculate the probability for a particular value like x equals to 1 or x equals to 2. For a continuous variable, we try and calculate this particular probability, which means what is the probability that this x lies within the range a and b. So instead, we'll need to find the probability that x falls in some interval. And that interval, that probability is basically PDF. So let's read this, study this with an example. So just clear my screen. Yeah. So let's take a fast food chain. So they basically advertise that a hamburger they are selling is of a quarter pound. So basically they say that they sell a hamburger which weighs 0.25 pound, but we all know it isn't exactly 0.25 pound. It could be more or less. So a randomly selected hamburger might weigh 0.23 pound, or like less than 0.25, or they could weigh more than 0.25, 0.27 pound. So if we are asked to calculate what is the probability that a randomly selected hamburger weighs between 0.20 and 0.30 pound. So this is basically a problem of PDF. They are asking us to calculate what is the probability that the weight of the hamburger lies between these two ranges, like 0.20 and 0.30 pound. So this is an example of probability density function. So okay. So let's say we denote x. We use a random variable x, which denotes the weight of a randomly selected hamburger. So x is a random variable, and we know a weight of something will be a continuous variable, right? It can take values, or it can take infinite values. It can be 0.20 pound, 0.21 pound, 0.22 pound. So it is an example of continuous variable. So basically we need to calculate PDF where x lies between the range 0.20 and 0.30. So let's understand what PDF is by the graph. So suppose we take 100 hamburgers as the sample. So from the place we took randomly selected 100 hamburgers and weighed them, and we created a frequency table. So, and with that frequency table, we plotted this histogram. So each of this rectangular bar is the frequency. So if by this graph, we see most of the hamburger is of 0.25 pound, and few hamburgers are greater than 0.25, few hamburgers are less than 0.25. But what if we decrease the interval? So if we slowly start decreasing, the interval, our density curve will become dense. So now we have more burger at 0.25 grams, and like we have similar number of hamburgers at less than 0.25 and greater than 0.25. Slowly it is, as we increase the density or decrease the interval, we'll see. So as we further decrease the interval, we'll see that our the rectangles become so small that we can easily plot a graph out of it. So eventually the intervals get so small that we can rather make a curve by joining all the dots of the rectangle. So like in the previous slide, these rectangles, suppose we further split them, so we can easily join the top of each of the rectangle and get a curve. So that particular curve is PDF curve. So this is the curve which we get after making the interval as small as possible. And so this curve is denoted generally by fx. So this is a standard we follow, and this is basically PDF probability density function, where now for our question, as according to the question, we wanted to calculate this particular probability that a random variable x is between these two ranges. So suppose this value is 0.20 and this value is 0.30. So this area represents PDF. So if by any way we can calculate this area, that would be the probability that our random variable lies between these range. So basically the area, the blue area is is the probability that X lies between 0.20 and 0.30. So this is all the concept of PDF. Um, mathematically, we can calculate PDF as a definite integration of fx from a to b. So in our case, it would be fx from 0.20 to 0.30, and this will give us the probability um, that our random variable lies between this range. We can solve this definite integral and get the value. It would be same as the area of the curve I showed before. So this is all about PDF. Now we'll move into hypothesis testing. So basically, hypothesis is a statement which needs to be proved. So suppose you did an experiment and you found that a certain drug is effective against, let's say, body pain or headache. So if you can't repeat that experiment, then your result is of no use. Nobody would take your result seriously. It could be just by chance that, okay, by luck that experiment was successful. So basically, we try and prove our experiment by some observation that, okay, the experiment which I did was useful, that the result can be repeated. So basically we are testing whether our results are valid, or whether the result happened just by chance. So it is a test. Hypothesis is a test between expected data and observed data. Expected and observed. So something we expect the experiment to do and something which we actually observe in the experiment. So it is a test between these two. And um, like suppose a new medicine you think might work, so you would do a hypothesis testing and you would find out whether that new medicine is really effective or it was just one time that it worked, or a way of teaching you think might be better. So like there are a lot of testing going on whether online studies is better than the offline one or vice versa. So in situations like these we do hypothesis testing. Like it can be really anything at all as long as you put it to test. So if you can prove it, you can do a hypothesis testing there. So for any hypothesis testing, we usually start by declaring null and alternative hypothesis. So before doing any actual testing, you need to define two things: null hypothesis and alternative hypothesis. So okay, so basically a null hypothesis is basically something which is equal to hypothesized value. So like suppose the previous example which I did for the two drugs. So it could be like if the drug is not effective. So if the drug is not effective, that's basically null hypothesis. Okay, the experiment which we are doing is not effective, is not bringing any new change. So those would be null hypothesis. And alternative would be something like, okay, the drug which I just invented or which I just found out is effective. So something you want to be true, or you believe it to be true, or hope to prove true. So those things are those things come under alternative hypothesis, and the opposite one comes under null hypothesis. So the null hypothesis always predicts there is no effect between the variables. So an alternative basically is like there is some effect, or there is some improvement on the test you're doing. And usually we try and reject or nullify the null hypothesis. So basically we come up with an alternative hypothesis that explains the phenomenon, and we try and work towards rejecting the null hypothesis. So this is all about null and alternative hypothesis. Um, like let's understand this with an example, because for any experiment, the first thing is declaring null and alternative, and people find it difficult to decide what is null hypothesis and what is the alternative hypothesis. So I think that's important to understand. So let's take this example. A researcher thinks that if knee surgery patients go to physical therapy twice a week instead of 3 times, their recovery period will be longer. Average recovery times for knee surgery patient is 8.2 weeks. So like this is our problem statement, and we are trying to find out what is the null hypothesis here and what is the alternative hypothesis. So usually the hypothesis is generally hidden in the question itself. So what is the expectation of the researcher? He expects that recovery period will be longer. So something which you expect or wants to prove it to be true is alternative hypothesis, and we use the notation mu A depicting alternative. So we want the researcher expects the average time to increase. So this would become your alternative hypothesis. And what's left? What's the opposite of alternative hypothesis? Null hypothesis. So the only case left is that the average recovery time won't increase. So either it will stay the same, 8.2, or either or else it will decrease. So might be less than or equals to 8.2. So these are the null. So this becomes your null hypothesis, and this becomes your alternative hypothesis. Now let's take one more example. What if researcher does not have any idea what will happen? So he has no clue whether the exercise program he is suggesting would increase or decrease the recovery time. So the problem statement says that a researcher is studying the effects of radical exercise program on knee surgery patients. So basically, there is a good chance, that therapy will improve recovery time, but there is also the possibility it will make it worse. Average recovery time is 8.2 weeks. So the researcher isn't knowing whether that exercise program will improve the recovery time or will make it worse. So in that situation, what would be the alternative hypothesis? That the researcher expects either it will improve or it will make it worse. So either the average recovery time would be greater than 8.2 or would be less than 8.2. So basically we can say it won't be equals to 8.2. So this becomes our alternative hypothesis, that our average recovery time won't be equals to 8.2. And what if the experiment fails? Then this means that our average recovery time will be same. So it will still be 8.2. So this becomes your null. This becomes your alternative. So this is how we define null and alternative hypothesis. Once we have the, sorry, just clear my screen. Yeah. So once we have the hypothesis, for any hypothesis testing, these are the 4 steps we follow. First of all, we just declare the hypothesis, the one we just studied, the null and alternative. So we declare the null and alternative hypothesis. That is the first step. Then we choose the type of test we want to do. As I said in the beginning, we have different types of tests: t-test, z-test, ANOVA test, chi-square. Like there are numerous types of tests possible in statistics. So depending upon different situations, we select the test we want. Once we know which test to perform, we calculate the test statistics involved. So for t-test, we calculate t-value. For z-test, we calculate z-value. For ANOVA, we calculate f. For chi-square, we calculate chi-value. So depending upon the test we select, we calculate that particular value. And then once we have the result, we interpret our result. So once we have the value, we try and find out whether we are rejecting the null or we are accepting the null. So these are the basic steps we follow to perform any hypothesis testing. Moving on, now we'll discuss some of the tests. So first test we are trying to discuss is z-test. It is basically used when we are trying to compare 2 population means. And we try to see whether the mean of the population, mean of the 2 groups are same or different. And we generally do z-test on normal distribution, and z-test assumes that we know the standard deviation of the population. So let's again understand this with an example. I think that will make it more clear. So there is a high school, and 25 students were selected from that high school, and they were made to complete a preparation program for taking the SAT test. So these 25 students wanted to take the SAT test. So they went into a preparation program, and the sample average is 536. So after taking that preparation program, uh, the samples average is 536 in the SAT exam, and the population average is 500 with a standard deviation of 100. So the question is, are these students SAT scores significantly greater than a population mean of 500 with a population standard deviation of 100? So what does the question say? Says that there was a uh, preparation program for SAT. From a school, 25 students were selected. They went through that preparation program, and then the average of that 25 students, let's use, okay. So let's use X bar. So X bar denotes the sample's average, sample mean. So the average is 536. So that is the average of 25 students once they went through the preparation program. But the population average mu, I'm sorry, the population average mu is 500, like uh, of the whole school. So that is 500 and have a standard deviation of 100. So now we are trying to see whether this particular value is significantly greater than this value. So first of all, first step is formulate the hypothesis. So we want to show that the sample mean, like the mean of the students, 25 students, is greater than the population mean. So this is our alternative hypothesis. So the null would be just the opposite. So it is like sample mean is not greater than the population mean. So we did the hypothesis statements, null and alternative. Next step is so next step is to choose the type of test. So for whenever we want to compare a sample with its population, we choose z-test. So like in our example, we wanted to compare 25 students with the population of the school. So we will choose z-test, and we need to keep in mind for z-test, we have to know the standard deviation of the population. So in our case, we were knowing that, we knew the standard deviation of the population, so we can perform the z-test. So this is the z-statistics, z-value, which I was talking about. So this is the formula which we do it. So this is the population mean. This is the sample mean, this is the population mean, this is the standard deviation of the population, and this is the number of samples. So since we knew all these values, we could go ahead and do the z-test. So we put in the value. So 536 was the sample mean, 500 was the population mean, this was the standard deviation, and we had 25 students, so number of samples, and we got the value 1.8. So this was the third step, find the value of test statistics. So we just got z value as 1.8. Now once we have the z value, we would interpret the results. So for z score, we have the z table. So this is the z table. You'll get it online, or it is everywhere in the books, or you can just search it online. Like you just have to type z table and you'll get it. So we got the z value as 1. So we got the z value as 1.8. So we'll go to our z table and we'll find 1.8. So right here is 1.8. And since the decimal value is 00, we'll go to this 00 and we'll find the corresponding value. So we got the value as 0.9641. And so we'll subtract it by 1 to get the p value. So we'll get the value as 0.0359. So the p value is 0.0359. Now, once we have the p value, we compare it with our alpha value. Now, alpha value by default, we take it as 0.05, that is 5%. What it means is we are accepting at least up to 5% error. So in our experiment, up to 5% error is allowed. So we try and see if that error is less than 5%, we accept the alternative and reject the null hypothesis. So in our case, we got the value as 0.0359, and since 0.0359 is less than 0.05, we can reject the null hypothesis. So so we rejected the null hypothesis and accepted the alternative hypothesis. And what it means is that the preparation program resulted in significant improvement in SAT score. So like those 25 students did not just by luck perform better in SAT exam. It means that that preparation program has some statistical importance and is helping students improve the SAT score. So like this is an example of z-test. This is done when we are trying to compare our sample with the population. So moving on, now moving to t-tests. This is the test which we use to tell how significant the differences between groups are. So suppose we have two different groups and we want to see which group performed better. So to compare the differences between groups, we use t-test. And a t-test could be of different types. One is paired sample t-test, and other one is independent sample t-test. So like for I'll just give you an example for each one of the tests. So suppose for independent sample, you had two different groups. So you had a group of male students and you had a group of female students, and you want to compare which group performed better. So you had two different groups. One is male group, one is female group of students, and you wanted to compare their test scores, maybe their scores in the maths exam, same. So in the case of two different groups, we use independent sample t-test. For paired sample t-test, suppose we wanted to compare the score of the same person. So like I gave an exam, say GRE exam, and I scored 310. And then I went through some training and I scored 320. So my score before that training and after that training. So if we want to do some, we want to see if there was a significant difference, that would be paired sample t-test. So like same person's score is compared before and after some intervention. So suppose this is an example which we can where a drug company may want to test a new cancer drug to find out if it improves life expectancy. In an experiment, there is always a control group, a group who are given placebo. The control group may show an average life expectancy of 5 years, while the group taking the new drug might have a life expectancy of 6 years. It would seem that the drug might work, but it could be due to just a dumb luck. So basically, a drug company created a new cancer drug and they wanted to test it. So we have two different groups. One is control group. One is the control group and other is the real group, like the group on which we are testing that drug. And on the control group, we have plus 5 years, and on the testing group, we have plus 6 years. So we'll perform the independent t-test and find out whether that t-test, whether the drug is actually significant or it's just some luck. So that is t-test. So this is the formula to calculate t value, the t statistics, where this is like paired sample t-test. I'll just quickly run through an example. So suppose a sample of, there were n students. So like there are 20 students, and this is the score of the students before the module. Like before studying the module, the teacher asked them to take the test, and after the students have seen the particular module, they were asked to take the test again. So this is the pre-module score, this is the post-module score, and it is of the same students. Like the group remains the same. So this would be paired sample t-test because the same student is taking the pre-module test and the post-module test. So now the teacher wants to see whether the module is helping the students or not. So we can quickly perform this paired sample t-test. So the first step is to calculate the difference. So we'll just quickly compare the calculate the difference of the pre and post. And once we have the difference, we'll calculate average of the difference, x of d, and then we'll calculate the standard deviation of the difference. And once we have those two values, so right here is the average and the standard deviation. Once we have these two values, we'll just put it into the t statistic formula. It was average by standard deviation divided by number of samples square root. So we got 3.231. And degree of freedom is number of samples minus 1. Since we had 20 students, it is 19. So for t-test, we need these two values, the t-statistic value and the degree of freedom value. And once we have these two values, we can go to the t-table. So since it's the t-test, we'll go to the t-table. And now the degree of freedom is 19. So we go here. And again, the confidence level, the alpha value I was talking before, we set at, so it's like 0.05 or 5%. So that is 95% is allowed. So we go to 95%, and the corresponding value is, I think, 2.093. Yeah, so the corresponding value is 2.093. So we got the critical value as 2.093. So now we have the actual t value, the t critical value, which we got from this table. Since the t statistic, this value 3.231 is greater than the t critical, we say that we'll reject the hypothesis that the mean difference is 0. That is, the pre and the post scores are same. That means the module, the intervention is helping students score more. So this is an example of paired sample t-test. Again, this is for independent sample t-test. So this is how we calculate the t-statistic for independent sample t-test. This is used between two unrelated groups, like the example I gave before, female. One group is female, one group is male students. So if we are trying to compare the means of these two groups, this is the formula which we'll use. So x1 bar is like average of group 1, x2 bar is the average of group 2. Again, S1 and S2 are the standard deviations of group 1 and group 2 respectively. And N1 and N2 are the number of samples in group 1 and group 2 respectively. For independent sample t-test, we have two different types, one with equal variance and other is non-equal variance. Let's not go into that detail, but this is a general formula which we use, and I think I have an example for this also. So suppose students reported their typical time to run a mile. Okay, so these are different students, whether they can be athlete or non-athlete. So 0 represents non-athlete and this is athlete. So non-athlete is running a mile in this second and an athlete is running into this second. So these are the different times taken by athletes and non-athletes. And so we have two different groups, two independent groups, athletes and non-athletes. And we want to see whether which group is performing better to run a mile or scoring less time, taking less time to run a mile. So now we'll use independent sample t-test since we have two different independent groups. So this involves testing whether the sample means among athletes and non-athletes are statistically different. So what again will declare the null and alternative hypothesis. So alternative hypothesis says that both the means would not be equal, like non-athlete and athlete would not run on an average of the same speed. And alternative is, okay, the mean of non-athlete and the mean of athletes are equal. So we stated our null and alternative hypothesis, and then we'll go on and calculate the t statistics. So again, x1, x2, s1, s2, N1, N2. We have to know all these values so we can calculate the average time taken by group 1, average time taken by group 2, their standard deviations, and number of athletes and number of non-athletes. Once we have all these values, we can just plug in the values in the T statistic and get this value. And again, we can use the T table and get the P value, and accordingly, if our value is less than 0.05, we'll reject the null hypothesis. Like that part remains the same. So this is how we do t-test, independent sample t-test. Now, as I was talking about confidence interval, like the 95% confidence and all those values. So basically, it is the range of values that is likely to contain the value of unknown parameter. So let's understand this with an example again. So suppose this mu, the black line, I'm sorry. Yeah. So the black line represents the unknown population mean. So that's the unknown population mean we want to calculate. So what we'll do is we'll take small samples of the population and try computing the mean. So like this is sample 1, sample 2, 3, 4, and so on. And so out of these 20 samples, we have these 20 samples, 19 samples contain 19 sample contains the population mean, only one sample did not. So like we can say confidently that out of 19 samples have our is same as the population mean, or will produce the same result. These 19 samples will have the same results as the population. So we'll have almost 95%, yeah, almost 95% confidence that our samples are as close as the population. So this is where the confidence interval comes, or the alpha value, or 95%, or 0.05 as the alpha value. So this is all about confidence interval. Okay, we have an example also. So suppose a manufacturer wants to know if the mean length of the pencils they produce is different than the target length. So they have set a target length, and what is the average length of the pencil. So they took a random sample of pencils and determined that mean length is 52 millimeters. And when they took out 10 or 20 samples, they found out that on average, this is the range they follow, 50 to 54. So again, this is 95%. So therefore, they can be 95% confident that mean length of all pencils is between 50 and 54. So which is a good thing. So this is how we use confidence interval. Now, the last topic I would want to discuss is type 1 and type 2 errors. So, okay. So in any testing or any experiment, we have errors. So for hypothesis testing, we have two different types of error, type 1 and type 2 errors. So, first understand type 1 error. So type 1 error is also known as false positive, and it occurs when a researcher incorrectly rejects a true null hypothesis. So our null hypothesis was true. It was true. The equation holds, but the researcher somehow incorrectly rejects it. So this means that you report that your findings are significant when in fact they have occurred by chance. So null hypothesis was that basically the result is by chance. So we somehow report that our findings are significant, but they occurred by chance. So this is type 1 error. And again, then we have type 2 errors. Type 2 errors is the opposite, which it is known as false negative, and occurs when researcher fails to reject a null hypothesis. So basically, when the null hypothesis is false and you fail to reject it, you make type 2 error. The null hypothesis was false, but you failed to reject it. So that is type 2 error. Yeah. So this is type 2 error. And so let's understand this again with an example. So suppose there was a research going on, and a researcher wants to compare the effectiveness of two medications. So there were two medicines, A and B, and they want to compare the effectiveness of two medicines. So the null hypothesis is the two medications are equally effective, like both have equal effects. And alternative is like obviously the opposite. So they are of unequal effects here. So they are not equally effective. Maybe one of them is more effective than the other. So what would type 1 error means? A type 1 error occurs if the researcher rejects the null hypothesis and concludes that two medications are different when in fact they are not. So basically, it will happen when the researcher rejects the null hypothesis and says that the two medications are different, but actually it was not. So actually the two medications were equally effective, but the researcher proved this. So what would happen if the medications are of equal effects? Uh, 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 this won't cause much problem to the patients because okay, the medications are of equal effect and the patients still benefit from the same level of effectiveness. But what if the the researcher has type 2 error? So the researcher fails to reject the null hypothesis when it should be rejected. So uh, we should have rejected this, and the researcher did not. So the researcher concludes that medications are same. Like we had to reject this, but we said this is true. We said that both the medicines are equal. So since both the medicines are equal, there is a chance that we said both the medicines are equal, and let's say medicine A was more effective. So what will happen? All the patients taking medicine B would receive medicines which are less effective. So that could be fatal, life-threatening. So type 2 errors are more serious compared to type 1 errors because we just said both the medicines are equal, but actually medicine A was more effective. So all the patients getting medicine B would not be treated as effectively as patient getting medicine A. So this is all about um, type 1 and type 2 errors. And I think that's all about the stats part. And now I would hand over to Jessica, where she can explain you about our support center.
Yeah, so Rocky, I'll have you proceed to the next slide for me.
Yeah.
And I'll go into talking about grad tutoring. We have two avenues for grad tutoring. There is graduate writing tutoring. So you can meet with a tutor to discuss course papers, theses, dissertations, and you can really discuss feedback at any stage of the writing process. And then we also have graduate statistics tutoring. So if there is any concept that we went over today that was unclear or that you want your questions answered, what you can do is schedule an appointment with any one of our grad stats tutors, and they can meet with you. All of these appointments are on a one-on-one basis, and you can go over statistical concepts or stats software. So all of these are one-on-one appointments. As I mentioned, they are 50 minutes long. They're all online, so you can access them from no matter where you are. And then all of our hours are in Arizona time, and it's pretty much Monday through Thursday, a little bit on Friday, and then Sunday evening. And also, for any of our graduate students, we do offer graduate workshops like these. So upcoming, just to put on your radars, will be an intro to our workshop and then an intro to SPSS on the stat side. And then there are a variety of workshops for graduate writing as well. And then we also offer over the summer a Success in Graduate Writing Camp and a dissertation writing camp. So those are week-long intensives. It gives you a chance to write or work on your dissertation and also get feedback and go to workshops within those. Those are the only things that we offer that are paid. Everything else is free, which is really awesome. And And then we also have writing group support. Best way to contact us is going to be on our website. You can visit tutoring.asu.edu. You can schedule an appointment today. So if you want to meet with one of our grad stats tutors, you can make that appointment. If you're also having trouble navigating the website, probably best way to contact us is through that phone number, that 480-965-9072 phone number. And then we do have socials. Those are not super active, but best way to kind of get information on upcoming workshops, schedule any appointments, or ask any questions is going to be on our website or via our phone number. And with that, I will open the floor to any questions and also go ahead and stop the recording.